Having already completed the discovery activity, hopefully you will find uh, what I have already. So I write it first in factored form. So opposite signs. So x minus 2 and x plus 3. But they want the standard form equation of that. So I multiply that out. No big deal. That's not too difficult. And when I add the roots together, 2 plus negative 3 is negative 1. And when I multiply them together, I get negative 6. Okay, no big deal. For number 2, I have roots of 5 and negative 1, so I write my factors with the opposite sign. So it's x minus 5 and x plus 1. No big deal. So when I multiply that out, I get x squared minus 4x minus 5 equals 0. And then when I add the roots together, I get 4. And when I multiply them together, I get negative 5. Okay? Now when I got 4 and 6, I have x minus 4 and I have x minus 6. So when I look at these and I write it out, I get x squared minus 10x plus 24 equals 0. When I add the roots together, I get 10. And when I multiply them together, I get 24. So by this point, there's a pattern here. The question is, do you see it yet? So how about if I make the roots negative 8 and negative 3? So again, I'm going to have the opposite signs. X plus 8, x plus 3. FOIL that out, I get x squared plus 11x plus 24. If I were to add the roots together, negative 8 plus negative 3, I get negative 11. And if I multiply them together, I get 24. So hopefully by this point, you're starting to see a real relationship take hold, where if you know the roots, okay, you could use those to help you get the equation without going through all of that process. All right? And we call this the sum and product rule, or sum and product property. Okay? And what it says is the sum of the roots is opposite the middle term. So if I look up here, that's negative 11, and that's plus 11. So if I add the roots together, and I change the sign, I get the middle term. The product of the roots is equal to the last term. It also happens to be the y-intercept. So, negative 8 times negative 3 is 24, and it's 24 here. And that's the case when you go up for all of these. The product is the last number. The opposite of the sum is the middle number. Now, that's all great and good, okay? But how is that necessarily going to help me here? So let's just take this scenario here. I have negative 8 and positive 4. So I want an equation in standard form without having to write the factors and multiply them out. So, first thing I'm going to do is I'm going to add them together. So their sum is negative 4. I'm going to multiply them together. And I get negative 32. What the sum and product rule says now is the opposite of this number, since that's negative 4, it'll be positive 4, is the middle term. When I multiply them together, that's the last term. And if you wanted to write these factors out, x plus 8 and x minus 4, we would get exactly this. Now, what's the benefit of this? Why am I doing it? This is just some curious thing. I can find other ways of doing this. All right, well, because we have to work with imaginary numbers, and finding the equations of things with imaginary numbers is quite complicated sometimes. So, what we have to do is, first, review multiplying some imaginary numbers in case you've never done it before. So let's just take some imaginary numbers and multiply them together and look at a couple properties, okay, of those. So let's just say I have 2i times 3i. I'm keeping it really simple to start with. I'm just going to multiply the coefficients together because I works kind of like a variable to start with. So 2 times 3 is 6. Then I times I is I squared. No big deal. But when I square I, remember, I equals the square root of negative 1. And whenever you square a square root, you get the number that's inside it. So this is the same thing as saying this. So whenever I square a square root, they cancel, leaving me negative 1. And when I multiply this together, negative 6. That is critical. Now, the other thing to remember is imaginary numbers come about because we're taking the square root of a negative number. And the only way we really run into those is if we're using the quadratic formula. We don't get them from factoring or anything like that. They come from the quadratic formula. And the quadratic formula has a plus or minus sign. So whenever these happen, there's a plus version and there's a minus version. And we have to be respectful of that. So imaginary numbers always occur in pairs. We call them conjugate pairs because one is plus or positive and the other is minus or negative. And we have to be mindful of that because when they ask us to write these equations, they frequently only give us one. So here's one for us to do. It says, write an equation with a solution of 3 plus I over 2. Well, we can't just write an equation with a solution of just 3 plus I over 2. All right? We could write one that has 3 plus I over 2, but it would also have to have 3 minus I over 2 because they occur in pairs. If you get the plus, you know that the minus is also there, and vice versa. Now, because the only way to make this happen is with at least a quadratic equation, and that's all the more really we're looking for right now, are quadratic equations. And we want them to have integral coefficients. So all the numbers are going to be whole numbers in the end. This is where the sum and product rule is quite handy. So the first thing I'm going to do is I'm going to add these together. Now remember, when we add fractions, we don't touch the denominator. So 3 plus 3 is 6. Positive I plus negative I cancels. So we get 6 over 2, or just 3 from the sum. That's nice. I'll take that any day of the week. So now what I have to do is I have to find the product. So I have to do 3 plus I over 2 times 3 minus I over 2. Now, for the top, I'm just going to FOIL these together. For the bottom, it's really easy. 2 times 2 is 4. Remember, when you multiply fractions, you do multiply the denominators. So for here, I'm going to do 3 times 3, that's 9. 3 times negative I is negative 3i. I times 3 is 3i. And I times negative I is negative I squared. So now I need to clean this up. I need to simplify it, okay? So the minus 3i and the plus 3i cancel out. That's nice. Now, I have I squared. Remember, I just said I is the square root of negative 1. And when you square a square root, you get just what's inside. So this is like saying 9 minus negative 1. because I squared equals negative 1. So this cleans up to be 10 over 4 or 5 halves. We are ready to write our equation. Because the sum and product rule says the opposite of the middle term, the sum of the solutions is equal to the opposite of the middle term. So my middle term for now is negative 3x. And the last thing is the product of the two solutions. So there's my equation. But I'm not done yet because we never have this. Okay? In order to save space, because paper was so expensive during the early days of publishing and of mathematics, they did everything in a single line, which meant they didn't use fractions. So they had to find a way to get rid of that. So I'm going to multiply everything by this denominator. So multiply everything by 2. And that will make this cancel out. So I'll get 2 times x squared is 2x squared. 2 times negative 3 is negative 6x. 2 times 5 halves is 5. And 2 times 0 is 0. This is my equation. That's what I'm looking for. So, the key ideas here are you have to recognize that if they give you one imaginary, you know the other one is also present. Okay? If they give you plus, you know there's also minus, and vice versa. Add them together, you should get a number without an I. If there's I still present, you've made an error. The product, the i's have to cancel. Okay, you have to get I squared some way, somehow, so that it disappears. Now, if after placement you get a fraction, remember you have to multiply to get rid of the fraction, and what you're going to multiply by is the denominator. All right? Last one. What happens if it's not an imaginary number, but it's some ugly radicals? It's some ugly irrational number like this. Okay? So they want us to find a quadratic equation with integral coefficients having roots that include 2 minus radical 5 over 3 and 2 plus radical 5 over 3. That's not very pleasant looking, but it's very easily done as long as you use the sum and product rule. If you try to use it by using the x minus the solution method and then multiplying it out, you're going to be working for a very long time. The sum and product rule is definitely the easier way to go. So here we go. The sum, 2 minus radical 5 over 3 plus 2 plus radical 5 over 3 equals, when we add, we do not touch the denominators. 2 plus 2 is 4. Negative radical 5 plus positive radical 5 cancels. No more denominators. No more radicals. Hooray. Now time for the product. So 2 minus radical 5, that's supposed to be minus, times 2 plus radical 5. So I'm going to multiply 3 times 3 to get the denominator. That's 9. Now I'm going to FOIL this top out. 2 times 2 is 4. 2 times positive radical 5 is positive 2 radical 5. Negative radical 5